Hello friends, this is Nisha Vasudeva from the RA College of Engineering and IT. Today we are here to discuss the topic computable language in the Turing machine. Computable means we can do the calculations like addition, subtraction, complement for this. So we are discuss the Turing machine work as a transducer, Turing machine work as a acceptor. Acceptor means the Turing machine read the input value and reach at the final state. This is the acceptor of or accepting of the string. So we already discussed this topic in the previous lecture. In this lecture, first we discussed the Turing machine work as a transducer. Transducer means any device that convert a signal from one form to the another form. That means if any machine read any of the input value, it gives some output value for this. So there are some steps for this. First, it convert the input to the output value. In this, start with the string on the input tape. After acceptance of the string, it left on the input tape. Next is the computation with the Turing machine. There are the computing functions for this with the Turing machine. Number one is the result of this function is applied to the input string x will be left on the input tape when the machine accept. When the machine accept means it reaches at the final state. When any function is applied and we get the final state, that means this is accepted by this automata. Number two is the function with the multiple argument can be placed on the input tape with the argument separated by some character. Like if we read the string 0 1 0 1, then for the 0 value we can represent some replacement symbol. For the 1 value we also use some replacement symbol for this. This is separated by some character. The next, computation with the Turing machine. The Turing original use of this machine used to calculate the integer value function. Integers are represented as a unary as block of single symbol. For example, if we represent 6, then it can be represented by 1 1 1 1 1 1. For the value 4, we can write 4 times 1. In our text, ones are used as a unary symbol and zeros are used as a separate argument. In the next, that is the language acceptance that already discussed. Acceptance means we get the final state. If we get the final state, then machine does not hold, it gives some valid value for this and the input string is correct for that particular machine. If this is not accepted by this, that means the reject the string and this input value is not valid for this particular machine. So we can define for this. Here is m is given. M means the Turing machine is given with the 7 tuples. Let w with the string in the summation closer value. This then w is accepted by m if this give the final state for this. These are the definitions for the acceptance of this. In the next, we are studying the Turing machine acceptable language and decidable language. Acceptable is that a language over some alphabet is said to be Turing acceptable if there exists a Turing machine such that L is equals to L of M. L is the language that is equals to the language generated by the machine M. And the Turing decidable language means a language over some alphabet is said to be Turing decidable if both the language and its complement are Turing acceptable. For the decidable language, we have to find the complement for this and the given language, and after the complement of this language, this is acceptable language. But in the acceptable language, we already know if we are check only the input string, that is reach at the final state or not. There are some important observation for this. In the first, as we see, something strange can happen in the Turing machine. As we see in this example, when Q naught read a blank symbol, it gives the replace this blank symbol, move on the right direction, and the state is Q naught. When it read the value 0, when it read the value 1, it gives 3 values for this. That means this machine never holds. That means this can never be stop this process. There are 3 inputs that can be divided into the 3 types. Number 1, as we see, accept the string. Number 2 is reject the string. Number 3 is loop. Loop means it is a never-ending process. When we give any input for this, then it remain in the same state. Next is the role of the Turing machine. There are some functions for this. Number 1 is as a language acceptor or recognizer. Number 2 is as a computing device, that is the transducer. Next is a function, that is the language acceptor. There are 3 possibilities occur on the given input string. Number 1 is the Turing machine M eventually enters ACC means acceptance of this and therefore hold and accept. Number 2 is the Turing machine M eventually enters queue reject or crash somewhere, or that means reject this string. Number 3 is never occur. That means neither acceptable nor rejectable. This is in the infinite loop. This is never ending process here. That is the three functions or three possibilities in the language acceptors are present. Number two is, or function 2 is computing device. In this computing device, a function f we have defined n maps to n is said to be computable function of key argument if there exists a Turing machine M hold with a tape consisting of 0 power m for some value m. That means for some value m, this is a infinite input length. That means this never be stop. We can read symbol 0 0 0 infinite time. In the second, a Turing machine may compute a function of one argument, a different functions of two arguments, and so on. If the function f I1, I2, so on ik is defined for all I1, I2, ik, then we can say that f is total recursive function. So there are two functions for this. Next is the example, that is the description of Turing machine for fx is equals to x plus 1. There is a function f function is defined, we have to find out, and one value is added to some x value. Unary representation is used in order to do any arithmetic operations on a Turing machine. That represent like 0 is represented by 1, 1 is represented by 2 times 1, 2 is represented by 3 times 1, 3 is represented by 4 times 1, and 4 is represented by 5 times 1. Next is the example of this. Design a Turing machine to add 1 to any number, same x plus 1. So start in the state 1. If the state is 1, then the current input is 1, then write 1 and move right and stay in the state 1. That means when any state read one input value, the 1 is replaced by one value and it moves in the right direction and the state remains same. In the next step, if the current state is 1 and the current input is b, then b is replaced by symbol 1, that is the right one, and move to the state 2 and move right and hold. Next is Turing machine instruction that already defined. This 1 is replaced by 1, 1 is replaced by v, or 1 is replaced by 1, move in the right direction, and 1 is replaced by 2. This is the state for this. The state 2 does not exist, so hold. This is represented by the diagram. When one read one input value, this 1 is replaced by 1, move on the left direction and remain on the same state. When it read the value b, this b is replaced by 1, move in the right direction and reach at the state 2, that is the halting state. That means there is no process is possible for this. That means there is we have to stop this process here. Next is the Turing machine work as an adder. Adder means we can add 2 or 3 machine into a single machine. That is example of this. And this Turing machine, as we see, there is an input string is given 1 0 1 1 0 1 1 1 0 1 1 0 1 1 1. Here hash is present on both of the sides. These are used for the blank symbol. In this we have see when 1 and 2, these are the states for this. At the first one state, this is the starting state, the input value is 1, replaced by 1 and move in the right direction. That is represented by the arrow, left or right arrow. And when it read the input 0, write the value 0 and move right direction. Same for this, we can represent it by this diagram. In this, adding on the tape, when n is added to m, then we can find the final answer n plus m. We can implement this, then start the adder. First, we look for plus. That is the first state, that is the starting symbol. There is an input plus, right plus, move left. And next we reach at the second state, that is the look for the digit. We have find the plus value, that is the operation for this. Now we are finding the digit for this. What is the next digit for this? Now either 1 or 0. So we can start 1 1r as we see in this slide. Next is 0 0r. That means 0 is replaced by 0, move in the right direction. In the second step, this if we get x value, this x is replaced by x, move on the left direction. We can assume for this. Now after finding the digit for this, we have see when 0 Second state, read the value 0. This 0 is replaced by x, move on the right direction, and result is 0. Next, if we see this one value, this one is replaced by x and move on the right direction, adding to the one value. As see in this diagram, we repeat this step or until we get the final answer for this. And in the third state, we see adding to the 0. There are the two possibility, this 1 and 0 be added, or at the fourth state we can see 0 and 1 be added for this. Then what is the output for this? And if in the third state, when we see 1 and 0 is added, then we can see hash is replaced by hash and move in the left direction. Then again we have looked for the digit. And the fourth state, we reach at the sixth state, that is also look for the digit. Same for this, we can repeat this step until we get the final answer for this. We can see in this slide also, you can understand this. We are adding 0 and 1. If we are getting hash value, then for the hash value we are again look for the digit either 0 or 1. We can find the value 0 or 1. We can add 0 0 1 1 0 1 1 0. According to this, we can find the answer for this. In the 7th state, we see 0 plus 0. In the 8th state, 0 plus 1. In the 9th state, 1 plus 1. Same for this. If we get the hash value, same process is applied. At the 20th and 21st step, we return to the next digit. There is a no carry for this. And in the 21st step, there is a return for the next digit and there is a carry 1. That means we have to repeat this step. If we add 1 plus 1 as a binary number, we get carry value. So according to this, we can repeat this step until we get the carry value. And we have to stop this process if there is a no carry. That means we have to we have the final answer for this. This is about the Turing machine as a transducer and the Turing machine as a acceptor. Thank you for